Download this code from codegive.com, link in the description below. Certainly. Google I/O 2019 featured numerous discussions on deep learning, including its applications in solving challenging problems across various domains. Below is a tutorial that covers key concepts in deep learning, along with a code example using TensorFlow and keras. Deep learning, a brief overview. Deep learning is a subset of machine learning that utilizes neural networks with many layers, deep networks, to model complex patterns in data. It has been particularly effective in areas like image and speech recognition, natural language processing, and game playing. Key concepts. 1. Neural networks, the basic building block of deep learning. A neural network consists of layers of neurons, where each neuron receives input, processes it, and passes the result to the next layer. 2. Activation functions, functions that introduce non-linearity into the model, enabling the network to learn complex patterns. Common activation functions include relu, sigmoid, and tanh. 3. Loss function, a function that measures how well the model's predictions match the actual labels. The goal of training is to minimize this loss. 4. Optimization algorithms, algorithms used to update the weights of the network to minimize the loss function. Examples include SGD, ATOM, and RMSprop. 5. Overfitting and regularization, overfitting occurs when the model learns noise in the training data rather than the underlying distribution. Regularization techniques, like dropout and L2 regularization, help mitigate this. Example problem, image classification. We will build a simple convolutional neural network, CNN, to classify images from the SAFAR10 dataset, which contains 60,032 x 32 color images in 10 classes, example airplanes, cars, birds, etc. Prerequisites. Before you start, ensure you have the following libraries installed. Step-by-step implementation. 1. Import libraries. 2. Load and pre-process the data. 3. Build the CNN model. 4. Compile the model. 5. Train the model. 6. Evaluate the model. 7. Visualize training history. Conclusion. This tutorial provided a basic introduction to deep learning and a practical example of using a convolutional neural network to classify images from the SAFAR10 dataset. The fundamental concepts of neural networks, activation functions, loss functions, and optimization were covered. As you delve deeper into deep learning, consider exploring more complex architectures, transfer learning, and advanced techniques like data augmentation, batch normalization, and ensemble learning. Further resources. Deep Learning with Python by François Chollet, https://www.manning.com/books/deep-learning-with-python. TensorFlow documentation, https://www.tensorflow.org/learn. Kaggle competitions, https://www.kaggle.com/competitions. Feel free to experiment with the code, tweak hyperparameters, and try different architectures to improve your model's performance.